Welcome guys, Sizwesakhe Academy, and this is the Global Classroom. We are still on arithmetic guys, and we're still on addition and subtraction, but we are finishing up with addition and subtraction before we go to multiplication and division. This is what I want to add on subtraction and addition, so that we may understand the terminology, the results that which we get in addition and subtraction. Meaning, whenever we add, the result is sum. That is the result. The result is a sum. When we are adding, that is a sum. If it's plus 5 plus 2, what we get is a 7. Because the signs are the same, it's a plus, but we don't necessarily put a plus. As you would know, at times we would say 5 plus 2 is equal to 7. We put a plus here because to show that we are adding the 2, but we already know that 5 is a positive, just like in our number line. These numbers 2, 3, we don't necessarily put a sign. We don't usually put a sign, but here we are specific. We do put a sign. We do put a sign as a negative. On the left of the 0 on the number line, the numbers are negative. On the right of the 0, the numbers are positive. Just wanted to remind you of that, guys. So we don't necessarily put a line. So 5 plus 7, so what we get is a sum. That is what we get. But also, if we are saying minus a 5 minus a 2, we get a minus 7. Now, if you remember very well, in the number line we said we've got a 0, we've got a 1, we've got a 2, we've got a 3, 4, 0, minus 1, minus 2, minus 3, minus 4, right? And we said if we are going this side of the number line, we are adding. And if we are going this side of the number line, we are subtracting. Right, guys? Okay. We are coming this side on the left of the 0 on the number line. We are subtracting when we are going towards the right of the number line, the 0 of the number line, we are adding. Even on this side, if we are going this way, we are adding. Though it's on the negative side, we are adding. If we are going this side, we are subtracting, though it's on the positive side. Right? But I want to explain this to you, because now you would see it's a minus 5 and a minus 2 is equal to minus 7, and I consider this as a sum. Both this, I also call this minus 5 minus 7 as a sum rather than as, which means it's an addition rather than a subtraction. As a result, I call it a sum. Consider this, we are going to town. This is your way to town. On your way to town, what are you doing to your kilometers as you are going to town? We say you are adding your kilometers, right? Now, consider coming back from town. Are you subtracting kilometers as you are coming back from town? No, you are not. You are still adding. What changed is the direction. Direction. That is what changed. Hence here, we have a minus 3 and a minus 2. And we say minus 3 minus 2 is equal to minus 5. You are adding, but you are going this side. The direction changed. As you were going to town, you considered it a positive direction. You are coming back the same distance you went, but now you are coming back. You are going the opposite direction and you are still adding. So I just wanted to explain why do we say this, we are still adding, yet it's going on the negative part of the number line. It's this side, it's going this side. A minus 5 and a minus 2, I would have to add minus 5 here and add minus 6 and add minus 7 here to get to this minus 7. So it's a minus 5. Here is a minus 5, that's where we are starting from. And we add a minus 2, we are going 1, 2, it takes us to a minus 7, which is here in our number line. So why do we say we are adding even though we are going to the negative? Because initially we said when we go negative, we are subtracting. When we're going positive, we are adding. On the right side of the number line, we are adding. On the left side of the number line, we are subtracting. I just wanted to show you that even though these both are negative, -3 and -2, they make up a -5, and we consider it as adding, coming this side. But all that changed here is the direction. This is just telling me that I'm coming back. Here I was going there, but now I am coming back. I'm not going there anymore. I'm coming back from where I went. So I went 4 kilometers this way. Now I'm coming back 4 kilometers. All that changed is a direction. Here I was going. Now I am coming back. It's negative. But it doesn't mean that if I'm in a car or cycling or anything that has an odometer or a speedometer that records the distance and the speed, it doesn't mean that the distance I'm minusing now when I'm coming back. No, I'm not minusing. I just changed direction. I went that way and I reached my destination. Now I'm coming back to here. And this is my destination. Here is my destination. Here was my destination, and this is positive, this is negative. But I'm not subtracting anything. I just wanted to explain that part on the number line so that you don't get confused. Why are we saying it's +5 + 2 is equal to 7? We are adding, even when it's -5 - 2, -7 is the answer, yet we're still saying we are adding. Why are we not saying we are subtracting? Yes, of course, -5 in the number line is greater than -7. It is true. But this side, we are just changing the way which we were going. We were going that way. Now we are coming back. It gives the same distance we are traveling. It's just the direction that changed. Only the direction that changed. So I thought I should explain that before it confuses you guys. Why are we adding when we have two negative? When we have two negative, because if you look, what we do, we say -5 - 2 is a -7. So what we're basically saying, if the signs are the same, we add the numbers. 5 + 2 is a 7. 5 - 2 is a 7. Just that this side, because the signs, we take the sign, one of the signs here, because they are both positive. So this one becomes positive. And we take a sign because they are both negative. This one is a -7. That is what we are doing here. So I thought I should quickly explain that before it causes any confusion or that it shows that I don't know what I'm talking about. No, believe you me, I do. I do know what I'm talking about. So when we add, there is a sum. Like we did, +5 + 2 is equal to 7, -5 - 2 is equal to -7. Right. When we are subtracting, the results, what we get from our subtraction, if I'm taking something and I'm subtracting something out of something, it means I'm taking away something from something. The result is the difference. What I get is a difference. What am I saying? If I'm given +5 - 2, the answer that I will get here, which is a 3, is what we call the difference. This is the difference from this. It is a 3. So the difference between 2 and 5 is a 3. Let's go back to our number line and we say 0, 1, 2, 3, 4, and 5. The difference between 2, here is a 2, and a 5, here is a 5, is how many units? We are starting here. This is our 0 unit. So we have how many units to a 5? 1, 2, 3. That is a difference between these two numbers. That is why we call it a difference. When we are subtracting any number from any number or anything from anything, we call that a difference. The result is a difference. Even if I have -2, so +2 minus a 5. +2 minus a 5. Let's go to our number line. Again, here's any confusion. -1, -2, -3, -4, and a -5. right? So we are where? We are at a positive 2. Here is our positive 2. And because of this negative, it tells us we are coming this way to the left of the number line. We're going how many units? 5 units. Let's start. This is our 0 point at 2. Say 1, 2, 3, 4, and 5. It takes us to a minus 3. So the answer here is a minus 3. Right. Now, the principle here in subtraction says, in addition, it says because the signs are the same, you add the numbers and you take one sign. Right. So here it's a minus 7, not a positive 7. Here is a positive 7. Like, you know, we don't usually put it as I've left it here. We don't usually put the positive sign. But for clarity, I thought I should. So here we've got a positive 5, a minus 2. We said it's a 3. A positive 2, a minus 5. We brought it to a minus 3. We've just proved it on the number line. The principle here says, when we are subtracting numbers like this, because the signs are not the same, we subtract the numbers. So we say 5 minus a 2 because the signs are not the same. And then we take the sign of a bigger number. We put a 3, and then we leave the sign of a bigger number. The bigger number here is a 5. So this is a positive. Hence, I didn't write it, but I just want to put it here. Same here, a plus 2 minus 5. Signs are not the same. We have a positive, we have a negative. They are not the same. Unlike here, they were the same. Here, they are not the same. So since they are not the same, we subtract the numbers. 5 minus a 2, we get a 3, and we take the sign of a bigger number. The sign of a bigger number here is a minus because it's a sign of 5, which is a bigger number. Minus is a sign of 5. Positive was a sign of 2. Minus is a sign of 5, and we leave this as a minus a 3. This is it. So we take the sign, we subtract and take the sign of a bigger number. That is what I wanted to show you guys. And this does away with subtraction and addition. But since we are moving to, I might as well finish this, we are moving to multiplication and division. Let's come to multiplication here. Multiplication. When we multiply two things, 2, 3, 10, 20, 50, doesn't matter how many they are, the result we call the product. Excuse me. The result is a product. So we add, we get a sum, we subtract, we get a difference, we multiply, we get a product. 3 times 2 times 1 times 4. The answer of this, 3 times 2 is 6 times 1 is 6. 6 times 4, 6, 12, 18, 24 is the product, is what we call a product. This is what 24 is a product here. And then we come to division. These terms are very important, guys. You will see as we go on. Division. What we get when we divide, if you say 6 divided by 2, when we divide, what you get out of the division is what we call a quotient. That is what we get. When you are multiplying, you get a product. When you are dividing, you get a quotient. When you are subtracting, you get a difference. When you are adding, you get a sum. This is very important, especially when we get to do word problems, where you are given a statement. They tell you, we saw had 2 cakes and he added to get a sum of, or a sum of so many numbers, or a product of this. It's just giving you an instruction of what you are to start thinking of. A product of X, a product of whatever, a quotient. When they say you already know, just for the fact that they use products, you know you are multiplying. The fact that they use subtraction, they use the difference, you are subtracting. When they say a sum of 2 numbers, you are adding. A quotient of, or they tell you a story and they already give you an answer. 6 is the quotient of something. You already know what they have done. They have divided. It's the information they give you. So it's quite imperative that you understand these things. Know these things and understand. Add, you get a sum. When we add, we get a sum. When we subtract, it's a difference. When we multiply, it's a product. When we divide, it is a quotient. It is imperative that you understand these things. Otherwise, you will remain confused at all times. You will not even know what to do. When we add, we don't get a difference, and when we subtract, we don't get a product. When we multiply, we don't get a quotient. When we divide, we don't get a sum. You need to know what you are getting when you're doing what. When you add, you get a sum. Subtracting, difference. Multiplying, it's a product. Dividing, it's a quotient. That's what I wanted to let you know, guys, before we move into the next part of this. In division and multiplication, let me start with multiplication. Let me start with, we have 6 times 2, 6 times minus 3, 6 or 4 times minus 1. Let me put it this way. In multiplication, we either use this sign or we use remember, I have told you that the two signs never follow each other. So like here, what we had to do was to put this here, right? But in multiplication, it's a bit different to addition. Remember, in addition, we had plus 2, minus, and then we said minus a 2. And then we said when you are subtracting a negative number, it's the same as adding it to its counterpart. So this becomes a 2 plus 2, right? That was addition. In multiplication, it's a different story. You are allowed to get rid of this if you are using brackets. You see, as I have done, I got rid of this. Instead of saying 6 times and a bracket and a 2, this simply means it's multiplication. The brackets alone, they just simply mean it's multiplication. When you come across this 6, it means it's multiplied with a 2. Like I've done here, 4 is multiplied with a minus 1. We are not adding here, we are multiplying. These give me the information that I have to multiply here. I am not adding anything, but I'm multiplying. I'm not subtracting, I'm not dividing, I am multiplying. When I come across something like this, it's a multiplication. It's a multiplication. Thought I should clarify that because we are getting closer to the gist of mathematics now. And then we come to division. Six divided by 2 is equal to 3. This sign is the same as saying 6 stroke 2. This is the same as this. It just tells me I'm dividing 3. It's also the same as 6 divided by 2. You see, we've got this sign, it's telling me I'm dividing. I've got this sign, it's telling me I'm dividing as well. I also have this sign here, this line going straight horizontal. This one is slanting, it's like a forward slash. It's the same as this one. It tells me the same message as this one will tell me and this one will tell me. These are very important things because at times they cause confusion if you are not aware of what it means. This is division. This is not a percentage sign. A percentage sign would have this. Then this is a percentage sign. Then this is a percentage sign. So this is not a percentage sign because it doesn't have the zeros. If it had the zeros, we would say 6% of 2. This is not what it's saying. What it's saying, we are dividing. It's a division sign. It's the same as this one, the same as this one, and the same as this one. Yep, thank you. Let's move on. Now I want to come out to something which is called brackets and precedence rules. These are brackets. Pardon my handwriting, guys. Brackets and precedence rule. The purpose of this brackets and precedence rule is to do away with ambiguity, to clear ambiguity. But for me to further explain, it would be best if I do an example. You will see what I'm talking about. Let's get on with it. Let's say 14 minus 3 times 4. Let me put another 14 minus 3 times 4. Right. 14 minus 3 times 4 and 14 minus 3 times 4. So let's start. 14 minus 3 is 11 times 4. 11 times 4 is 44. Right. We say 14 and then we say minus 3 times 4 is 12. 14 minus 12 is 2. Which is which? This is the ambiguity that I'm talking about. And the reason for this brackets and precedence rule is to clear this ambiguity. Which is which here? Who is fooling a who here? So let's get down to understand these rules and see how they help us solve such dilemmas. Right, the first rule says, in this precedence rule, the first rule says, we take a sweep from the left to the right. Straight sweep from the left to the right. Here I am, I take a sweep from here and I come this side which is towards my right. In one sweep, it comes here. So sweep from left to right. That's rule number 1. Number 2, it says evaluate division and multiplication first. We evaluate division and multiplication first. We deal with that first before we do anything. Number 1, we sweep from left to right. So our direction is always from the left, it's going to the right. We never start from the right and go back to the left, or start in between and mix and try and see how we mix this. No. It's straight from the left and it goes straight through to the right. Secondly, we evaluate division and multiplication first. That's what we do. Thirdly, once we've finished evaluating division and multiplication first, we evaluate plus and minus, which is secondly. Firstly, we firstly deal with division and multiplication. Then secondly, we deal with addition and subtraction. Right, I want us to start now. I'm going to erase this at the top. Hope you are clear with this. You saw the ambiguity. Hope now you want to see how we solve such problems. Let's get down to it. Let's move on, my brothers and sisters. Oh, I love maths. Now, assume we have okay, 4 plus 5 times 6 minus 12 divided by 2 plus 6 times 1. Right, we have this. Our first instance is to move from the left, sweep from the left to the right. That's our first aim, our first goal. We move from left to the right, right? That's our take. So before we do anything, we start from left, we go towards the right. And our second move is to evaluate the division and the multiplication sign first. Whichever comes first of these, it's not necessarily that it has to be division or or multiplication. Any that comes first, it could be multiplication and division. Just want to clear that so that people don't get confused. And when you come across a multiplication before a division, you leave. No, we deal with it once in a one sweep, right? So we evaluate these. So we have, because we are dealing with multiplication and division, we will start with that. Hence, we drop F4, and then we say plus 5 times 6. This is our first part. 5 times 6, that is 30. Right? And then we say 30 minus a 12. Sorry, minus, let me leave it because we have to deal with this. Minus, what is, we come to this. 12 divided by 2 is a 6. We put a 6 and we have a plus. We've got a 6 times 1, which is a 6. We have dealt with these, right? We have done away with this. We are left with the plus, minus, and a plus. Hence, our third part, our third rule, third instruction is, if we evaluate positive and negative secondly, which means we started with the multiplication and division, now we have to evaluate the positive, and hence we go 4 plus 30 minus 6 plus 6. Minus 6 plus 6 equals, we can say it equals 0. Whether you put a negative or a positive, it's up to you. Negative 0 plus 6 and 6, they can't basically cancel each other. We've got a 4 and a 30, and this is a 34. So 34 minus 0, the answer is 34. That's how we get to do this. Right, it's brackets and precedence rule. That's how we get to do this. This is our answer. We started with dealing with multiplication and division and multiplication. We dealt with that first. We left the positive, negative, and the positive later. Once we had dealt with that, then we got our 34 minus 0, 6 minus 6, 34 plus 30 plus 4 is 34 minus 6 plus 6, it's a 0. 34 minus 0 is 34. Here is our answer. So this is our sweep. Now the question is, but you spoke of brackets and we haven't seen brackets yet. Let me do this now. I'll use the same sum, and I will say, let me put these brackets here. Right. I just want to wipe this. Probably there won't be much of a difference, but I just want to wipe this and do this. Now, when you see brackets in a sum like this, right, we had dealt with, we swept from left to right, we dealt with evaluation, negative and positive, multiplication and division, and we then followed with the plus and minus, which was left after we had dealt with division and multiplication, right? Now, we have the brackets. Now, the rule says, when in a sum like this, there are brackets, you start with brackets first. Brackets must be your number one. Your brackets must be first. I know I should have put this here, but they left it so that we can get a clear picture why we have to now consider brackets. And soon you will know why we have to consider brackets first. Right? The brackets come first, which means we go back to 4 plus, we've got this on brackets, 5 times 6, we said it is 30. It's still the same. Minus 12 times 2 is 6, plus 6 times 1 is 6. It basically takes us back to where we were, which is 34 minus 0, 34. The numbers could change, it could be any other number. I just want to show you the principle, guys, and so that you know what we are talking about, right? So the brackets come first. They take precedence. If you see brackets in that sum, I showed you one where there were no brackets, because it is possible to come across a sum where there are no brackets. But if you do come across a sum that has brackets, brackets override all the other rules. It becomes number one. So brackets here, they become number one. The reason they didn't say I didn't use them first was to first make you understand this one without the brackets, because there is always the possibility of getting a sum that has no brackets at all. Right. So this is what happens, and this is what we get if we get the bracket. But I just want to show you something that I think many of you are aware of. I'm wiping this off as well. Right. We have something called this BODMAS. Others say BOMDAS. It's basically the same thing, it's just that they swiped certain things. This here is brackets. This is off. This is here division. This is multiplication. This is multiplication. This is division. And this is addition. And this is subtraction. Right. Brackets of division, multiplication, addition, and subtraction. There's usually an and, though we don't really write a for an and, but it is there. And subtraction. And on this side, it's brackets of multiplication, division, addition, and subtraction. It is the same thing. It's just how you want to put it. It's the same thing. Like you saw on that sum, I had said it's either you start division and multiplication, and then I said it doesn't matter, it could be multiplication and division. That is what it is. Others call it BODMAS, others call it BOMDAS. It's up to you how you call it. It's just, this is just an acronym. The one that suits you, use it. BODMAS, it just flows for me. BODMAS, BODMAS. Unlike BOMDAS. Unlike BOMDAS. For me, BOMDAS is a bit, but BODMAS for me does it. Okay. So I think I should just subtract. Even here on addition and subtraction, you can swipe. Subtraction could be here and addition could be here. Subtraction here and addition here, it's still the same. But just for an acronym has to have that flow. It has to be a word on its own, but it stands as an acronym. So let me wipe this. We're about to. Now, this is what I want to finish with. And the question in this, it says, let me put it this way. It's a 4 plus 5 minus bracket 20 divided by 2 plus 6 times 2. And I put this in brackets, or maybe not 6 times 2. Let me leave 6 times 2 as it is. And minus 6, open bracket, 2 minus 1, close brackets, and close the big brackets. Now we have another situation here. We have a bracket within a bracket. What do we do in that case? We have a bracket within a bracket. So we have our numbers, we have our equation as it is. Here it is. But we have brackets within a bracket. Now, what is the rule on that? The rule says you start with the brackets within. And then once you've dealt with the bracket within, you deal with the bracket without. This is within, this is without. The brackets within, this stroke C for me is width. This is width. It just simply means width. So please don't mind that. Within and without. So what does it say? We start with the brackets within the brackets and we follow with the brackets outside of the bracket. So we have 4 plus 5 minus open bracket 20 divided by 2 plus 6 times 2 minus. These are the 6. These are within the bracket. 2 minus 1 is 1. So we deal with this. Right. And then we have 4 plus 5 minus into 20 divided by 2 plus 6 times 2 minus 6 times 1 is a 6. We close the bracket. We still leave this which is outside the bracket. We deal with now the without bracket. We've dealt with the within bracket. We are dealing now with the without bracket. So we have a 4 plus 5 minus, open my brackets, 20 divided by 2 is 10 plus 6 times 2 is 12 minus 6. I close my bracket. 4 plus 5 minus open bracket 10. I drop 10 and I have a plus. 12 minus 6 is a 6. 4 plus 5 minus open bracket 10 plus 6 is 16. That's what I have. So it's 4 plus 5 minus. You can see here between a bracket, between the bracket and the minus, there is no number. By virtue of there is no number, it doesn't mean that there is no number. There is a number and the number is 1, but we don't write that 1. Why? Because if I multiply 1 with 16, 1 times 16 remains as 16. So it's the only way for me to use to get rid of these brackets. So there is an unknown one, unseen one, so to speak, but it is always there. That one is there because there is a sign here and there is a bracket. Had there been a negative here, I would have had to multiply this negative because a bracket, like we said, a bracket is the same as multiplication, right? Had I would have had to multiply negative times negative would have given me a positive. Those are the signs in multiplication. I'll get to the signs just now. So since there is no negative here, we didn't have. So this becomes a 1 times 16. That's how we get rid of the bracket with a 16. And 4 plus 5 is a 9 minus a 16. And the answer is this is a positive. So number 1, it tells me we take the sign of a bigger number. 9 minus 16, we are left with a minus 7. That is our answer. So that is what we do. We start with this 4 plus 5. We deal with it. We deal with the within brackets, inside brackets. Once we are done with inside brackets, we deal with the outside brackets. I still use the brackets here, but just for clarity, you can skip that and say 6, 2 minus 1. But just for clarity for my marker to see, whoever is marking my work, to see, because if I skip many steps, it might cause me problem because some markers are not necessarily maths teachers. They just have a memorandum and they follow. And in the memorandum, if the steps are there and you don't show those steps, you are gone. Yet a teacher who does maths would understand, but I'm not sure who's going to mark my paper. Therefore, I've got to make sure that I put everything that I have to put correctly in its right place so that I do not lose a mark. right? So we dealt with the outside inner brackets, we solved it, we're left with outside brackets, we dealt with outside brackets. Once we had dealt with outside brackets, we came, because we were left no more with any brackets, because brackets signify a multiplication, so we had to do away with multiplication. And when we came here, we were left with signs, positive and negative, and we dealt with that and we got our answer here. This is what I wanted you guys to see. In closing, truly closing, I know last time I said this is the closing part, but this is the proper closing part. It's deal with multiplication and division. Multiplication and division. I don't really like to have long videos, but at times if you want to teach thoroughly, it pushes you to get there. And one thing good, whenever you are tired, you can always pause and come back later to finish that video if it's too long for you. I know some people's concentration is very limited, and that's not wrong, that's not a sin, but if you are tired, pause, come back later and finish your work. It's doable. Now this is multiplication. I have plus times plus would equal to a plus. Minus times and minus is equal to a plus. Plus times and minus is equal to a minus. Minus times a plus is equal to a plus. Sorry, minus times a plus is equal to a minus. These are the signs in multiplication. Same thing with division. A plus divided by a plus is a plus. A minus divided by a minus is equal to a plus. Minus divided by a plus is equal to a minus, and a plus divided by a minus is equal to a minus. They're basically the same. These are the signs, and it is very important that you know these signs. If you have a plus 2 times plus 4, the answer will be plus 8. Minus 4 times minus 3, the answer will be plus 12. That's how it works. These are the signs, and you have to know these signs off by heart. With addition, remember, with addition, it depends on the numbers. Plus, plus, plus. It is a plus. A minus, plus, minus. It is a minus. Depending on the signs, the plus, plus, minus is dependent on the side of the number. Which number is larger? If plus is a larger number, then the sign would be like, if plus 5 minus 2 like we did before, it would be a plus. It's the same thing. Same thing with subtraction. A plus minus a plus. It depends on the numbers. It depends on the numbers, because we said when you add this, when you add a positive number to, it's the same to a negative number. It's the same as subtracting it from its counterpart, right? So do recall those things. Do go back to that video and watch that whole thing. This is where I want to finish. This is where I want to stop today. Guys, if you like the video, please thumbs up, share to as many people as you can. It is very important, guys. When you share, you are basically inviting people to come and join this classroom. Remember, this is a global classroom. And by the way, it's not limited to people you know they know maths, or you want them to know maths. Even those you think they've gone past the stage or the age of wanting to know maths. For instance, if you go to your parents and you say to your mother, please help me with maths, or to your father, please help me with maths, and they say, go to your mother, or your mother says, no, don't try me with maths, go to your father. Those are the people we need for this class, so that they revive their maths skills, their maths understanding, because most of them don't like maths because they were somehow hurt, somehow, I spoke about this at length in my very first video on what maths is all about, to who has to, and how to master maths. It has nothing to do with intelligence. It has nothing to do with, yes, of course, it's to an advantage if you are intelligent. but maths only needs love and discipline. If you can master those two things, you'll be a good friend with maths. And if you can start with little, you will see in the progression of time, you will grow and grow and grow in the love of maths and in the understanding of mathematics. Guys, thank you so much. Don't forget to do that. Thumbs up. If you like the video, please do thumbs up, share, subscribe, and don't forget that bell, the notification, guys, so that each time we release a video, you are the first to be notified. You'll first to know that we've released one. Thank you guys for having me. Love you so much. God bless you. Thank you.